Welcome back, everyone. I am absolutely thrilled you're here for another explainer. Today, we're diving into a really cool everyday mystery. You know that thing you've probably experienced a dozen, maybe 100 times while just walking down the street or sitting in traffic. It happens in an absolute flash, but the mechanics behind it are just fascinating. We're going to unravel exactly why ambulance sirens seem to magically change pitch. So let's get right into the physics of it all. Section 1. The siren pitch illusion, a trick of the ear. Picture this. You're just waiting to cross the street. An ambulance barrels toward you, right? And it's got this piercing, high-pitched wail. But the very second it passes you, the pitch just drops dramatically. Okay, let's really dive into this. Did the ambulance driver suddenly flip a switch? Did the actual physical siren equipment change the notes it was playing? Because your ears are definitely telling you that two totally distinct sounds were just produced. But the answer is actually a resounding no. The actual frequency produced by that siren, it stays exactly the same from the moment that ambulance leaves the hospital to the moment it arrives. The hardware isn't changing its output at all. What is changing, and this is really the core of our mystery today, is what you are receiving. The source itself is completely constant. It's the journey of that sound to your ears that we need to investigate. Section 2. Sound acts as waves. The baseline rules. Now, the baseline physics here are beautifully simple. Step 1. A parked siren sends out sound waves with a fixed, totally unchanging frequency. Think of it like ripples in a pond, just moving steadily outward. Step 2. Because our ambulance is completely stationary, those waves reach you exactly as they were created. And step 3. You hear that exact same fixed frequency. Without motion, there's absolutely no illusion. The pitch the siren makes is exactly the pitch your ear receives. Section 3. Approaching and receding, the squeeze and the stretch. But, an ambulance isn't exactly designed to sit still. So let's look at what happens when it moves, starting with side A on the left. When the ambulance is moving toward you, it's literally chasing its own sound waves. Because it's moving in the exact same direction it's broadcasting, those successive wavefronts get crowded together. They're physically squeezed. This means the wavelength actually decreases. And this brilliantly illustrates why that crowding results in the higher pitch you hear. Now check out side B. The moment it passes and begins receding, it's basically driving away from the sound waves it's sending back toward you. The wavefronts are pulled apart, they're stretched. So the wavelength increases and bam, the pitch drops. The crucial point here is how this works mathematically. It's like a fundamental balancing act. The speed of sound is basically constant in the air around us. And since velocity equals frequency times wavelength, we've got this very strict relationship. If that speed is locked in as a constant and the approaching ambulance makes the wavelengths smaller because of that crowding effect, well, something has to give, right? To keep the whole equation balanced, the frequency absolutely must get larger. And a larger, higher frequency is exactly what your brain interprets as a higher pitch. Let's move to and see how this builds when the ambulance speeds away from you. We're going to apply the exact same mathematical logic here. The speed of sound is still our constant. But because the vehicle is receding, the wavelength spreads out and increases. If the wavelength gets bigger on one side of our scale, the frequency has to drop to maintain that constant speed of sound. The math literally forces the frequency down, and your ears instantly register that sudden, super noticeable drop in pitch. Section 4. The Doppler Effect. Naming the phenomenon. So, we've successfully decoded the mechanics of the squeeze and the stretch, and it's time to officially unmask the name of this phenomenon, the Doppler Effect. It's simply a phenomenon where physical motion fundamentally changes the frequency that you receive. It causes the frequency to be higher when the source is approaching you and lower when it's moving away. It's just this elegant, completely invisible distortion of reality caused purely by movement. Now, before we wrap up today, our source material leaves us with a truly mind-blowing twist. The Doppler effect applies not just to sound, but also to light. No way, right? But it's true. The exact same rules of waves compressing and stretching due to motion, they absolutely apply to the light waves traveling across the vastness of space. Which leaves us with this final thought to really ponder. If the simple motion of a vehicle down your local street is enough to physically warp the pitch of a siren you hear, how is that exact same wave-stretching phenomenon warping your perception of the light reaching us from the farthest edges of the entire universe? It really makes you look at a passing ambulance in a whole new way, doesn't it? Thanks so much for joining me for this explainer. Keep asking those big questions, and I'll see you next time.